I didn't see this motion. What's P equals to? P equals to -3. What about Q? Give me an equation first. 6Q equals to -15. So Q equals to -15 over 6, which is negative what? 5/2, is it? Okay. Then we have, but this is only if they are equal lah. So for two matrices to be equal, they must have the same order, right? So in this case, it is 2 by 2. So the other matrix must also be 2 by 2, and all the elements must be the same. So the 8 over here and the 8 over here, 7, -7, -7. So everything else must be the same. So try it for let M blah blah blah, and they say that M equals to N. Okay, let's check whether the order are the same. Okay, both are 2 by 2 matrices, so order is the same. Everything else must be the same. So we need to form an equation. Give me a first equation. 3x minus 2y equals to 4, -3. Okay, this is my equation number 1. Equation number 2, 4y equals to -14. Equation number 2. Do you need me to do the simultaneous equation for you? Only I'm sure you can do it, right? So what do you get? X equals to? What do you have for x? -4 over 2. 4 over 3. Okay, what about y? -½ All of you got this? Shufi got it? I never do. Haven't finished. Is it correct, Junior? Hey, hurry. Who is right? Who is wrong? Okay, let us take equation number 2 minus equation number 1. 6y equals to -11. Y equals to -11 over 6. Is this correct? Yes. Okay. X equals to? So hurry if you're wrong. Jolene, is this correct? Okay, then you go and find yourself. I'm sure you all can do this, right? So over here, if I want matrices A and B, they represent sale from some items from two shops of a company. So one company has two shops, and they want to find everything out, add everything up. So we see that 320 will be added to 273 to arrive at 593, and so on and so forth. The order you do your addition is important. Same row, same column, with same row, same column. Okay, and I hope you have realized and noticed that in your textbook, whenever they describe a matrix, they will bold it, B-O-L-D. When you are doing your work, can you bold it? You cannot, so you just write the capital letter. That's good enough. Okay. Now here there is a condition. There are two matrices of the same order. Then the sum of A plus B is the matrix obtained by adding the corresponding elements in A plus A and B. Now what happens if they have a different order? Can add or not? So for example, on my board, N and D, both are 2 by 3 matrices. What if I've got over here like this? Then can I still add them up? So it becomes 2 by 2. Can add or not? Can? Can add? Cannot add already. Okay? You are not able to add them up because the order is different. Because when you try to add them up, then what happens over here? If you try and subtract, then what happens over here for the last column? It doesn't make sense anymore. The story is no longer complete. Okay? So they must have the same order. Okay, so skip all this. And now we are at this page. Flip to this page. A plus B is the same as B plus A. Just like our normal primary school maths, where you add two numbers up. 1 plus 3 is the same as 3 plus 1. Whether there are brackets or not doesn't matter also, because you can remove the brackets, they all say the same. Then over here, there's this O there's this O. A plus this capital letter O equals to A. What then can you conclude about this matrix? A plus something equals to A. What is that something? Yeah, it is 0, right? In normal maths, if I say that A plus B equals to A, so B must be equal to 0. Over here, matrix plus something, you get the same matrix, so this must be some equivalent of 0. In matrix, it is known as the 0 matrix. There is a name for it, and it has the same order as A. Okay? So 0 matrix, they are also known as null matrix. Have you heard of this word before? Null. When have you heard it? Set, in the previous topic, right? Null set. Null basically means nothing. So in this case, it's all zeros. It's filled up with zeros. Okay? So this one over here is called a null matrix because it is filled with zeros. This over here is also a null matrix because it is filled with zeros. As long as it is completely filled with 0, it is called a 0 matrix. It is known as a null matrix. Can? Okay. So now, example 5. We've got matrix A, matrix B, matrix C. Add them all up. We just add them up normally, which I think I don't need to go through with you. Do you want to try it 5? Or it's a waste of time? I think it's a waste of time too. I'm sure you can do it. Okay, now, example number 6. This time, these are more common types of questions that we can see. They usually give you a story behind it. So on Monday, Peter walked 3.6 km, ran 8.4 km. Okay, there's a difference. One is walk, the other is run. So this is given by the matrix. What is the order of this matrix? Can you please tell me what's the order? How many by how many? 1 by 2. 1 row, 2 columns. Always row then column. So on Tuesday, he walked 4.7, ran 10.2. Represent with matrix T. So simple, just transferring information only. M plus T. Okay, M plus T. Even though it is just 1 row, you still need to put in your brackets to indicate that there are matrices. So put that one inside, get the answer. Straightforward. Interpret. This is the one that sometimes students are not confident of. You just need to do it logically. The first element over here, 3.6, represents walking. Walk. Then this one is run, right? Then on the second day, Tuesday, he walked 4.7 and he ran 10.2. When you add them up, the result must still be walk and run because the order didn't change. Make sense? Okay, so what does it represent? It represents the total walking distance and the total running distance completed by him 2 days respectively. This is a very important word. Okay, trees inside, what are the elements? 0.4 and 0.4, 0.6. 1 mark. Find A plus B. So A plus B equals to 1.2 and 0.8. Am I right? Okay. During the the elements represent represent what? Total what? Amount of meat and vegetables cooked, okay, good, ED, in both dishes respectively. Okay, make sure you have all these keywords. Total amount of meat and vegetables cooked in both dishes respectively. Okay, please tell me the results of B minus A first. Yeah. No. Okay, how much? 14? 19? 0 and 6. Okay, part B. What do the numbers represent? They represent the decrease, okay, in blood pressure. Then for each patient after they take the pill. Okay? Can I? Part C. What does the element in the third row first column B minus A indicate? What does it indicate? What? Come on, you got one keyword already. Sorry, how much? There is a decrease. No, it's a 0 ma. So what does it mean? What does it indicate? That the pill did not have any effect. The pill did not have any effect. Okay, I can't seem to get the words out already. The pill did not have any effect. Okay. Your B. Okay, what do you have? No lah, you effectiveness. So how effective is effective? We've got numbers over here. It must mean something. Okay. Any other answers that you want me to verify? Otherwise, that's all for 5.2. Then we'll move on to 5.3. Okay. Now we have a multiplication of a matrix by a scalar. Okay. So before that, I want you to. So if K is a scalar, the scalar multiplication of matrix A by K is denoted by KA. K times of A. We don't put the multiplication, we just put K and then A. We know it's scalar. Every element in A will be multiplied by K. So I want you to try 8, 9 right now. Try 9. Okay, so these are the answers for try 12. For part B, Zhuo, is it correct? Okay. Then interpret the meaning of the element in the first row, second column. Where is my first row, second column? First row, second, okay, yeah, you're right, 61. So what does this mean? Interpret. So without me writing, 61 represents the total number of square raisins sold in 5 M packages and 4 N packages. Okay? So this is what I mean when I say it must be very clear. All the information is given already. So at the start, somebody said square raisins. Hey, come on, that's not even the full sentence. Okay, you need to be very detailed.